Hi friends, welcome back to my channel. So in this video we are going to learn one more topic, that is pipeline execution, and we will be explaining one of the taking an example. Okay, so let us go to the question. So what is the question given? So first of all we need to read the question carefully. Okay, so what is the question given? Consider an instruction pipeline with 5 stages without any branch prediction. What are those? IF, instruction fetch, ID, OF, EX, OW, and these are the like instruction fetch, instruction decode, operand fetch, and execute, and operand write. These are the 5 instructions, and stage delays for these instructions are 5ns, 8 nanoseconds, 12 nanoseconds, 7 nanoseconds, and 6 nanoseconds. Okay, so given there are 5 stages, right? Given how many stages are there? There are 5 stages. So given in pipeline there are 5 stages, right? In pipeline IF, that means instruction fetch, has 5 nanoseconds delays, stage delays. These are the stage delays. Okay, and ID, it has 8 ns. OF, it has 12 ns. And for EX, executed bus, 7 ns. And for OW it is 6 ns. Okay, done. Now after given, so what we need to do, there are intermediate storage buffers after each stage, and delay for each buffer is 2 ns. Delay in each stage we can say is the delay buffer. Let us say delay buffer equal to 2 ns. And the total number of instructions is a program consisting of 13 instructions. Okay, total instructions is equal to 13. Okay, done. Now is executed in pipeline processor. Execution instruction I5 is the only branch, and its branch target is I11. So in the I5 and its target is I11. If the branch is taken during the consideration of this program, okay, then calculate the time period of the each clock pulse. So first of all, what is the first question asked? First part A, what is the time period of each clock pulse? So already there are stage delays are given. So what we need to do, we need to find out what is the maximum stage delay. Okay, first we need to write what is the max stage delay, that is OF, right? And operand fetch, and that is 12 ns, 12 nanoseconds. Okay, and what is the buffer delay here given? Buffer delay BD, buffer delay is 2 ns. So the clock period will be the maximum stage buffer plus max stage buffer plus delay buffer or buffer delay, that is nothing but 12 plus 2, that is 14 ns. Okay, so it is nothing but think like take an example from the daily life. Think of it like a team working on a project. Each member takes different times to finish their part. The slowest member decides the meeting schedule. Even if others are fast, everyone must wait for the slowest person, and plus a 2 ns like handout time, like giving notes to the new teammates, like that. Okay, so in this way we have completed the A part. It's very easy, right? So that's why I'm telling, understand the concept, it will be very easy. And the next, show timing diagram with instructions on y-axis and time on x-axis. I will be explaining this as very simply. So instructions on y-axis, so it is this one and this one I'm doing. So these are the instruction y-axis, this is the y-axis, total 13, right? I4, I5, I6, I7, I8, I9, I10, I11, I12, I13. And here let us say the clock time here. Okay, and x-axis, what we need to do, x-axis and the time, cycle time, we can say 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Done. It is in y-axis and it is in x-axis. These are the cycle times, and then these are instructions. Done. Now what we have to do, we have to write the timing diagram. So first of all, in instruction 1, it will search for IF, again ID, OF, EX and OW. It will continue like this. So first of all, let me tell you one daily life example. Okay, so let us take like you are in a hotel. Okay, the waiter, like there are 5 items, like think like a starter, main course, soup, like that. There are 5 you have ordered. So everyone have ordered 5 things like that. Started soup, like soup, starter, some main course, some delight and the bill, at last bill. Okay, so what I am saying is, if the first person, I1 is the person, first customer, the waiter will provide the the dishes, the overall dishes for the first person, and after that, after completing all these steps, he will go to the second. Like this it should have to go, but as we have given without any branch prediction in the question, so once it's done, similarly for I2 in the second cycle, first time he will take the soup to the first customer, and second time he will take the starter for this first customer, and soup for second person. Like this it will continue. IF, ID, OF, EX and OW. And again here IF, ID, OF, EX and OW. And I4, IF, ID, OF, EX and OW. And for I5, IF, ID, OF, EX and OW. Like this you have to do. So once you came to I5, we have also given like it is changed from I5 to I11. Okay, so it is already given in the question. So at the I5, what the customer 5 told, I want to stop this at this time. I have ordered this executed one wrongly. I don't want this. Okay, at 8th cycle, you can see this 8th is in 8th cycle. So whenever you know the mistake, it is in which program? EX. The mistake is in EX. So up to 8th program, it will discard. This is the 8th cycle time. Okay. So for I6, if you can see here, I can write IF, ID, OF. That's all. This will be not done because it will be stopped. Like the 4th customer told, I don't want the the sweets. Okay. Again, this will be the wrong table. He has changed the table from I5 to I11. He changed from the table I5 to I11. So again, the starting will start from 11th table. But these are all the things that should not be done. Okay, the tables will be skipped. The person in the customer in the 5th table is going to move from, after eating these 3 things, he told that he will go to the I11 like table and he will start eating there. Okay, again from starting. So if it is stopped here, right, while eating the sweets he stopped. Okay, why I am telling this? Because EX is nothing but executing. Whenever the program gets executed, then only you can know whether either to stop or run. Okay, so I6, these 3 steps will be run, but after that it will be closed. Again IFID will be run and again it will be closed, and at last IF will be run at close. Okay, for I8 it will be like this. Now again these 3 steps will be I10, I9 and I10 will be not executed. Okay, you will be getting to know that this will be not executed. Then next from I10. So from where the cycle time is stopped, it stopped from cycle 8, right? From here it is stopped. So it will start again from I9. So for I11, it will start from I9. So IF, ID, OF, EX and OW. And similarly IF, ID, OF, EX and OW. And IF, ID, OF, EX and OW. So at the instruction I13, it starts in I11 and it ends in I15. Okay. So what's the question here given? Show timing diagram with instruction on x-axis and instruction on y-axis and time on x-axis. So that's all. If you draw this, it's enough. And C, calculate total time needed to complete the program. Okay. So we count here. If you ask me so what we will do here for calculating this, first instruction, take 5 instruction cycles. How many instruction cycles are there? Number of instruction cycles. For the first instructions, how many cycles it will take? 1, 2, 3, 4, 5. 5, right? 5. So 5 into 14. You can see why I am writing 14 here. If you can see here, clock period. So we are multiplying that with number of cycles into clock period, that is 70. And next, each new instruction completes every cycle in pipeline. Each new instruction, like this will be completing 14, like 70, this will be 70, like this. For every successfully completed instructions will take 70 ns. Okay, then for 13 instructions, it should take 13 plus 4 into 14, that is 238 ns, right? Yeah. Now, but most for like as already we have penalty, branch penalty, right? But we must account for. So here I have done a small mistake, sorry. Just leave this. So what you have consider, like for we have to calculate the total time needed to complete the program. So at the program is completed in instruction 13. Last instruction is instruction 13, and it is completing in the which cycle? It is completing in the 15th cycle, right? And so total, like what is the last cycle? Last cycle is equal to 15, right? 15th cycle it is completing. Okay, and for one cycle, how much, what is the clock period here? If you can see, clock period is 14. So what is the total time period? Total time period is equal to, what is the last cycle here? 15 into what is the clock period there? We have found that in A 14, right? 15 into 14, which is 110, 210, sorry, 210 ns. So this is the total time period. So it is the total time period when, like when after removing, they have in question it is shown, right? Instruction I5 is the only branch and this target is I11. So here if you can see, these three are run, but there are no use. And after that 9 and 10, instruction I9 and I10 are flushed. That means it's removed, not executed. So after this, after doing this only, we got the total time period as 210 ns. So that's all. If you write these things in the exam, right, it's more than enough. Okay, so what we have done till now, what are the given terms? There are 5 stages we have done, and we have written the number of second stage delays, like that. So after that, given the delay buffer and total instructions. Okay, now what is the first part? We have calculated the time period. So time period is nothing but what is the maximum stage delay and add the buffer delay. That's all you will find. And after that, I have explained you how to draw this graph as well, y-axis, x-axis. And at last, total time. How can you calculate the total time? What is the last instruction and what is the cycle time for that last instruction? That is multiply that with the what is the clock period. That's all. So thank you guys for watching my video. Let me know if I have to make any